So my name is Pieter Temmerman, and I'm working as a project innovation engineer at Ajinomoto Omnichem since 8 years. In this role, I try, and literally I try, to translate R&D dreams to engineering requirements. And especially for this project, I do it for my colleague.
My name is Kristof van den Berghe. I'm working 9 years for Ajinomoto Omnichem in Belgium, and I'm an engineering project manager automation. I'm also leading the automation advisory group, which sets out the guidelines, transfers the knowledge within the company, and explores new technologies.
Yep, so we are working for Ajinomoto Omnichem. It's one of the most beautiful chemical facilities in Europe. We are a CDMO, so a contract development and manufacturing organization, and our mission is to contribute to the health of humankind. And we are doing this by producing more than 1 billion life-saving doses a year. And if you ask me how we do it, well, some call it magic. We call it science.
So a small introduction. So Ajinomoto is a big group in the whole world. It's based in Asia, and we are a small part of it with Ajinomoto Omnichem. So we are a CDMO with facilities in Belgium, mainly in Belgium and India, and we are focused on the small molecule GGMP manufacturing. We have development labs in Belgium, as also a pilot plant in Belgium.
Yes. So, and here it is, an R&D dream, a big Lego block. So back in 2012, our R&D department asked us to build a modular continuous flow plant. So build out of all building blocks, so from there is like Lego, building all together the blocks, having together a full operational pilot plant. So my flexibility is key, of course, because, and believe me, in the mind of an R&D person, ideas can change really quickly. So later on, I asked some clarification about this project, and R&D director just told me, well, Peter, it's not that hard. We just want to produce, and we will do it with reactor type A. And if it's not working like we are expecting, well, we will take it out, put reactor type B in it, and start up the system again. And if pump 1 fails, well, we take pump 2 from the warehouse, put it in, and proceed. And if we have another project, well, then we'll just shuffle all those modules in a new order and start over again. So, and I was like, so I understand the ideas, of course, because we can reduce the time to market by going faster from R&D experiments to pilot production, and we can save costs by reusing equipment for multiple projects. But how to deal with this flexibility in an automation system? So, voila. We started in 2015 with building our building blocks. So I have some examples on the screen. We built continuous stirred tank reactors, we built retention time units, and we even built a photochemistry reactor unit. So I understood that traditional automation would not work in this application because, well, we'll do multiple processes or projects, and we understood that it would result in a lot of changes. And imagine the tons of papers that would produce in a pharma environment. So with that in our mind, we start building these blocks and put these blocks together, we get this. This was our first modular pilot plant for continuous flow. So we can see all the building blocks put together in what we call an equipment train. So from the beginning, we were aware that all these building blocks should be able to plug and produce. Sometimes I call it like the USB of the process industry. On a hardware level, we found a solution in the EtherCAT, the hot connect function of EtherCAT. This is providing us the flexibility to just live plug and play. Another challenge was on the software level, so in HMI. We were looking for an HMI system that could handle this flexibility. And in those days, so back in 2015, we found it in the lab world. And with those software, we were already able to control and to modify easily one of such an equipment train. It was mainly manual controlled with some automatic features.
So, as the demand from the market was increasing for our pilot plant activities, it was growing, and the demand was to have multiple trains possible to produce. And also to produce, according to GAMP 5, FDA 21 CFR Part 11 compliance. So we were looking for a system that could help us to make this GMP production possible. And with the software from the lab world, it was not really feasible. So we found out that all our requirements were covered by the Zenon platform.
Yeah, so maybe you remember from the introduction, I deleted the word impossible from my vocabulary. And so back in 2022, I went with all these requirements to the AGEMA exhibition. We were aware of a new standard which was under construction called MTP, and we were looking for more information about it. And we found out that Beckhoff was working together with COPA-DATA on this topic. So on the COPA-DATA booth, I came and I told, yeah, I want to have a library of all my skits, modules. I want to be able to flexible work with it in 2 parallel lines. I need audit trail, and I also want it in a GMP way. And, well, they just told me, well, it's possible. It's all integrated in our Zenon software. And I said, this may be too good to be true. So we started an experiment. Together with Beckhoff and COPA-DATA, we set up a proof of concept.
So thanks for the next slide, Pieter. So our approach of the proof of concept, it was really simple. We had already modules, so we took some modules and we took just a standard desktop PC. We modified our PLC software with the MTP toolbox we got from Beckhoff. We did not change any wire, and we had our best commissioning experience ever. It was really plug and play. We had no errors at all. And so it was really plug and play. Further on, we found out that the Zenon software was really intuitive. And with the help and the cooperation of COPA-DATA, and also, and I would like to recommend it, their online Zenon Academy, we were really quick in developing our solution. What we also saw is the scaling of Zenon. Like I said, in this proof of concept, we just had a desktop PC, and we did already recipes and everything. And today, we did our next project. We validated a complete network structure with servers running the Zenon platform and made our pilot plant GMP production proof. So, what is also very important for us is within our CDMO, everything is in an explosion zone. It means that we have every equipment has to be ATEX approved. Next to that, our skits are very small. So if you look to the MTP standard, it's developed to have on each skit a controller, which we did not want. So we looked to the MTP, and we saw that MTP was OPC UA based. And together with our partners, our suppliers, we looked for a solution. And so we found out that via the use of namespaces, it was possible to address multiple instances, so modules, from one OPC UA source, which made it possible to import them into Zenon and to make it possible. So our process equipment assemblies, they are built in TwinCAD with the MTP library. We export them and we import then it into Zenon, having the logics and the graphics available. And in this way, we are able to orchestrate. So the objects in Zenon, we can create a process orchestration layer called POL. And our first experience was in this proof of concept. And like here in the theater, a conductor leads an orchestra. Zenon controls our production trains. And so I come back to the innovation floor, and I give the floor back to Pieter.
Thank you, Kristof. So if we go higher in the pyramid, we see services. So every skid, every process equipment assembly, I should call it now, is performing one or more functions. These functions are configured as a service in the MTP standard. So they are so functions are configured. Functions are configured as a service in the MTP standard, and these services are then services like, for example, heating up the reactor or dosing raw material 1, dosing raw material 2. That are really functions of our blocks. Those are available for creating a recipe. And within that recipe, well, for each step, parameters are defining the state for each process equipment assembly. So it's like a state machine, according to ISA 88. So, and also other parameters or control strategies can easily be applied in the Zenon library builder, in the Zenon recipe builder. So another advantage of the recipe builder is that it's also available in runtime. So you can make a recipe in runtime. So a pilot plant engineer in our facility can create a recipe. So this solution enables us to control a complex process. Okay, so some screenshots over here. So we've built, back in 2015, our first kit. In 2025, we have the system fully operational in the Zenon platform with MTP. So that means we have in Zenon a library of all our existing skits. A pilot plant engineer can drag and drop them. And with one click, the process orchestration layer is completely generated. So the drag and drop function, that's all it's called the orchestration studio in the Zenon software platform. So that's happening over there. And after that, after the generation is ready, well, a full operational HMI system is ready. So the advantage of this is that on the HMI, only the used skits are visible. So there's no overload on information, and it is really resulting in a clear overview for the operator how to operate with the system, of course.
So this successful realization was only possible with great teamwork. We would really like to thank the multiple automation specialists and MTP specialists we talked to, our system integrator, for sure, Contact, we want to say gratitude, our suppliers, COPA-DATA and Beckhoff, to be able to do this project. Of course, there were obstacles, like for instance, interlocking between modules, which was not defined at that time in the MTP protocol. We had some issues with scaling of graphics, but it was solved by our suppliers. So the next step will be MTP 2.0, building more skits, and of course, Zenon version 15. Next slide, please.
Yes.
And as to conclude, we have a small movie of our proof of concept, and it's a short version of it. Pieter.
Yes.
Our pilot plant forms an essential part in the development process of new products. We do the scaling of chemical processes as studied and optimized in the lab. For the pharma customers, we're producing reagents, intermediates, and APIs in a CGMP-compliant way.
In our next step, we want to be able to run multiple independent processes at the same time. This requires much more flexibility of the operating and automation system.
This enables when changes have to be made. This can be done with a minimum of engineering, and as a result, a highly flexible and reusable plant is created.
During a proof of concept, we wanted to demonstrate that we can produce with 2 equipment trains in parallel.
With Beckhoff's high-performance PC-based control technology, we were able to aggregate multiple MTP modules on one control unit while still making them available to the process orchestration layer independently.
The advantages we saw in our proof of concept that we did with Beckhoff and COPA-DATA. So on our module, the challenges regarding size and ATAX are really accomplished.